Cool.
So today's going to be a fun day. We're just going to go through each of the projects that everyone did on linear regression, some small examples of how you can use linear regression machine learning models. And it doesn't matter if you got completely through to the end and you have some really interesting results, or if you got caught up on some bugs. That's part of the fun and part of the learning. So yeah, we'll just get started right away. So we have time for people to demo their little models, and after you get to show for a few minutes, someone else will maybe get to ask a question, or two people if we have time. So let's say yeah, bless you. Let's say Brayden, are you ready?
Sure.
Sweet.
Should I share my screen?
So yeah, you have an option to share.
Let's see.
Oh.
Okay. Let me 1 second. I'm just gonna pull up the data set that I'm using so you guys can see what it actually is. Give me
yeah.
one
What data set did you use?
It's schools that you put in the GitHub.
Was it the academic one? Yeah, the student performance.
Yeah,
okay.
It should be.
Oh, that's great, because that's the one that we were just having.
Okay. Anyways, it was something about like schools in Brazil, I think, somewhere.
Mm-hmm. We can't see the data set yet. Oh, yeah, now I see.
I'm saying it. Can you guys hear?
Brayden, are you still there?
Oh, there it is.
We almost lost you for a second. So I'm looking at. Oh yeah, here it is. Cool.
Okay, give me. Do you want someone else to go, and then I'll figure that shit out, and then we'll go after.
Oh yeah, are you having an issue?
I don't know.
All right. Okay, Brayden appears to be lagging. So let's say Felix.
All right, let's try. Give me 1 second.
Yeah.
So I wanted to use some real world data set. So I tried to find some data on some open data platform for the city of Seoul in Korea, where I live, and I found this data set that they share. It's the public for the public bikes. They have a bunch of data in there, including the registrations, new member registrations, and so I tried to predict the number of registrations by the age group of the new members, because there is a very strong correlation there. I already saw it in the data, so nothing too crazy, but
so there are people signing up, like registering as new members to use the bikes, and that's the data
right
point.
exactly. Yeah, so let me try to share my screen. I think it's this one. Let me know if you can see the screen.
Yeah, we got it.
Yeah, so as I said, there's nothing crazy. There's not even that much data, but I think it works. So this is just the EDA, right? In the data set that I uploaded, I kind of uploaded only part of the data. So it's just the month, the age group, and I changed it a little bit. Before there was some other characters in there, but this is basically teenagers. This is people in their 20s, in their 30s, 40s, 50s, and so on until 80s. And then there's the count of new users in different months. for every month of the year 2023. And then I basically put that in the model. There's a kind of a plot of the data here. As you can see, there's not as much data. There's some of the data is overlapping, but I tried to train a model on this, and then you have this kind of a linear regression here, and you can see that as age goes up, the number of new members goes down. It's not a perfect fit. I think actually, as you can see here, the number of new members in the years of like 10 to 20 is or 10 to 19 is lower. So actually, the people in their 20s are the highest new joiners, but on average, it kind of works. And so that's the linear regression, and then we have this evaluation of the error. And so this one is a little bit tricky for me to interpret. And actually, I asked James about it yesterday, I think, and maybe we can talk about this later, because I wasn't sure which line represents what. But I think how I interpret it is that the blue line is the actual numbers, and then the orange line would be the predicted values. I'm not sure, but so, and then the difference basically is the error, right? Yeah. Oh yeah. One thing I missed is you can. I predicted the new members for the age of 33, and then the outcome was 3,495. So yeah, you could use this to approximately predict the number of new joiners in a certain age.
Mm-hmm.
That's it.
Nice, Felix. I really like how you used real world data, and you went out and you found a data set for something that was interesting for you. Was it easy to import that data that you found?
Importing it was okay. I was not sure at first how to get data into this into this Colab notebook, but I managed to kind of mount my Google Drive to it. So that worked fine.
Can you show that part?
Oh yeah, sure. I think it says it's disconnected now here, but basically what I did is I just searched how to do it on the internet. So basically you can import the drive, and then you can let it navigate to the folder, right, where you put the CSV file, and then it can actually work with it.
Does anyone have any questions about Felix's the model that Felix trained?
Wait, Felix, do you mind copy pasting that from Google Colab and that part to the chat really quick?
Sure. This part here?
Yeah, that one, and then the next one.
I think that's the main one. The other one is just kind of checking if it's there.
Oh.
Yeah.
Okay.
Sure. If you want, I can probably also share the. I don't know if I can still find it, but I just found it online somewhere in a Stack Overflow or something like that. Yeah.
Okay, Felix, I'll talk about the different ways someone can import data into Colab. There are multiple ways. The one that you have used, it basically mounts your Google Drive, and then you can access whatever is stored in your Google Drive. So you can navigate to the Google Drive. You can copy files from there. You can usually when data sets are small, what we do is we don't mount the drives because the data set is small. We can just upload them on the fly. So you can do that. But when data sets becomes huge, for instance, you're working with some imagery data where it is 5 GB or 10 GB, that where it becomes much difficult to upload the files directly to the Colab. So what we do is we mount our drive. Mounting a drive is just simply, it's like plugging your flash drive into a computer where that storage then becomes accessible. So what
Yeah.
you are doing here is that you are mounting the drive, and then you can access whatever is stored there. In the beginning, Nishant, what you were showing, I think I spotted the problem, but then the screen went away. I'm not sure, but I think your files were zipped, so you need to unzip them before you can load them using pandas or something. That's what I saw, but I'm not sure. We'll talk about that. And Felix, the last plot that you showed, can you scroll down to it again?
This one?
Yeah, so here this code I just added, we added this just for testing. It's not like, it's not, someone doesn't usually evaluate it this way, but what's happening here is we take the predictions and we sort them, because if you plot them without sorting them, it would be basically fluctuating, and like there won't be an order. So what we do here is that we sort first the predictions of the model, and then we sort the true values, and then we plot them using a line chart so that we can see if the trend is being followed by the model correctly. So the blue one, by default, when you plot something in Matplotlib, the default color that they assign to it is blue. So the first one is blue, which is the prediction of the model, and then the second one, which is orange, is y test, which is the true output. But still, if you would like to be sure about it, you can add colors to the plot manually, where you can then, or you can even label them, saying this is the true output, this is the predicted output. James would show you those, how to do that. The question that I wanted to ask was, so you are using the age groups in order to predict the number of registrations. So the age groups, the feature basically becomes a categorical feature, what I saw, because you have the age group of 20 and then 30s and then and so on. So it is not a continuous or numeric feature. It is rather a categorical feature. So you're using a categorical feature in order to regress a value. That's interesting. Now I saw the trend; it was going downwards, and the line was following that correctly. So I think, yeah, I mean, it was a good demonstration of linear regression. It was interesting.
Yeah, so I think it's not the perfect, maybe not the perfect case, but for me, because James was asking if it was difficult, actually the most difficult part was finding data that can work with linear regression, because there's a lot of data out there, but a lot of it only becomes useful if you use multiple linear regression or like something more sophisticated, because otherwise it's kind of obvious already in the data, usually in the plot, but nonetheless it's interesting, as a training, as a study case.
Cool.
Yeah, so the goal was just like, to show you, or to that you can see for yourself how to take a code and then modify it such that it becomes useful for your own use case. So even though if you don't find correct data, or if it is not something very useful, that's perfectly fine. At least you now know how to take an algorithm and apply it and get some predictions. What would be different than other cases is that instead of using linear regression, you will be importing, let's say, SVM from the scikit-learn. The rest of the code stays the same. Or if you want to use somewhat more, like you can use XGBoost, you import it the same way, you train it the same way, you evaluate it the same way. So everything stays the same. In case of neural networks, the only thing that would be different would be that instead of importing linear regression from scikit-learn, you will be using TensorFlow to construct your own neural network. But that's the general workflow, and the majority of the code stays the same. That's why focus is not too much on coding things from scratch, because there are tons of codes available online. The goal is just to show you how to make use of them in order to so that you can solve your own problems with it and make good use of it.
Braden, are you good to go now? Want to try again?
Yeah, I'm good.
Okay, let's go to Broski over here.
Okay, let me share my screen. Yeah, so the data set that I was using is the student performance data set. It's one of the ones that Jane put on the GitHub. So yeah, I kind of just read through this. It was actually easy to import because they have code right here that just tells you how to do it. So you can just kind of run this code. It's like a Python package that you can import. But yeah, so the data it's basically trying to map like a bunch of different features about like a student's like home life and like their academic kind of habits to like their grades in school, essentially. So yeah, I guess like here's the first few lines. It has like things like their sex, their age, how big their family is, their mother and father's job, how much free time they have, how much time they study, and things like that. And then it maps it to their grades, which is over here. Yeah. So honestly, I was, well, first of all, there was a lot of things in the data that were kind of like strings, like not actually integers or like binary values that I kind of just had to remove so that they didn't interfere with like the plot or whatever.
Yeah.
And then, yeah, like there was not a lot of like high correlated value. That's like the first thing I noticed here. Like I guess the most significant thing is really the failures. So like basically like how many classes they failed impacts their grades. I think that's kind of like self-explanatory. But that's like the most correlated thing, and everything else is kind of very low or almost not correlated. At least with the grades over here. So what I actually chose to analyze is this field here, which is called DALC, which is the daily alcohol content or daily alcohol consumption. So I tried to map that to what their performance is in their first class. So yeah, that's my X. That's my target, which is this and this column here. So yeah, the like the data was actually quite categorical, as Naveed was saying. Like it's not really continuous flow of data or a continuous stream. It's more like they map something to like a value between 1 and 5. So it's either it's a bunch of overlapping lines. So it's not the best thing to train on.
And what are the axes there? I know you didn't change them.
Yeah. So this x-axis is their daily alcohol consumption. So it's a number between 1 and 5.
Uh-huh.
And then the y-axis is their grade in their first period course or their first period class.
So is that one between 1 and 5 shots of alcohol?
We can check the data set if you want. Workday alcohol consumption numeric value between 1 and 5. 1 is very low, 5 is very high. It doesn't actually give you much more detail than that. But yeah. And then this is a linear regression I trained. So I mean it's almost a horizontal line, but like you can see like you're slightly better off if you don't consume alcohol, and you're slightly worse if you do. But it's not a significant thing, so I guess you can drink as much as you want, really.
Actually, I have a comment on there, but I'll get to it at the end.
Okay. Yeah, so I predicted the value if you consume like the maximum amount of alcohol in a day, and you would get about a 10. I don't know what scale they're grading on either, so I don't know what. I guess I can first period grade between 0 and 20, so you get about a 50 if you drink every day, apparently. Yeah, I mean that's about it. This plot, I don't really, like I said, I don't really understand what this says. I think David was saying that this orange line was the predicted value, and then this was the actual values or something along those lines. But yeah, I guess that's about it. Well, I guess what I learned here is like data, I guess the structure of the data that you're using to train the model is very important, because like I don't think training a model on categorical data or like data that kind of overlaps a lot is a really like useful form or really useful thing to do when you're training linear regression, because it's like you're not really getting a lot of insight. That's just my kind of intuition.
Good point.
Yeah, that makes sense because the categories, as you can see, for alcohol consumption of grade 1, of 1, the quantity 1, you have a wide distribution of the grades, and then for 2 it is also distributed across, which just simply means that even if someone is consuming alcohol of 1, 2, 3, or 4 or 5, their grades are fluctuating across the whole axis. So it's not telling you something very significant. But
Hmm.
although I see a downward trend, which is kind of a slight downward trend, which is kind of linear regression line is kind of picking on that. So yeah, that's okay. I guess that works. The plot that you are confused about, let me try to explain it once more. So you get on the test set you have some true values, um, which you have set aside, and then on the features, like the features you have used and the model predicted something for those as well. So you have the true values for them, and then the model predicted values for them. If you So one way to compute to see how the model is performing is to compute a numeric value, RMSE, MSE, MIE, that kind of things, which can give you a quantitative analysis. But if you want to see visually if the line is, if the prediction, if the true values are being followed by the linear regression, like how closely it
Hmm.
follows those,
Yeah.
a good way to plot is a line chart. Now, if you try to plot a line chart without sorting the values, the values would be fluctuating a lot. Even though you can do that, the linear regression line would also be correspondingly fluctuating with it. But what I was doing just was that if I sort them, there would be a rising trend, and then I was kind of trying to see if the linear regression line is following that thing.
The important
So
thing about this chart is that the x axis doesn't matter. Like this could be in any order. It's it's just
exactly.
it's just see the difference between the two lines at each point.
So if it was a perfect prediction, the one line would be sitting on top of the other one.
Yeah.
I see.
Did anyone else use this same academic data set as well? Nishant, you used the same data set too, right?
Yeah.
So maybe we can look at yours next. But actually, Braden, there's one more thing I wanted to. Can you share that again? Just one more. I just one comment on your graph. So there's actually yeah. Let's look at the actual regression graph. Yeah. So there's actually this is just a fun comment, but there's actually a famous web comic called XKCD. I don't know if anyone's read it before. But one of the comics explains that when you're programming, a little bit of alcohol makes you a better programmer up to a certain point, and then it's actually a non-linear um, where a little bit of alcohol helps, and then a lot more makes you a lot worse. So actually, I think this graph actually confirms that because you see that you're actually getting better performance after a couple of drinks, and then after more further there's degradation. So that's could be
Well, we
really
don't really have the control case here. Like we don't have a student who doesn't drink at all. Like it's all like all of them drink a little, at least a little bit. We can't really like measure normal performance.
that's a good point.
Anyway,
Anyways, that's all I wanted to point out about this graph. And maybe Nishan, if we just want to for a few minutes, you could show where you got stuck. And since Braden has done this one as well, maybe he can show you, get you back on the right track.
Okie dokie. Okay. So I was doing what Felix was doing, trying to extract it from the drive, and I'm not really sure. How did you get the path? What is for that?
Braden, how did you import the data into the notebook?
So if you go to the data set, like the actual link that James put in the GitHub.
Okay. So I think Braden's suggesting an entirely different way of doing it.
Yeah, like I didn't bother with like downloading it and like
Without even
extracting anything.
downloading
You
any
just like there's a Python package that had the data set in it, and then you can import the Python package and then basically use the data set from there. And that's what I did.
Makes sense.
Oh, okay. So you literally just
Yeah.
I see.
Yeah.
So you just you run both those lines of code or both those scripts, and then you can use the data set from there.
Okay.
Which variables did you have specific variables that you wanted to look into?
Me?
Yeah. Or you're just trying to get the data imported?
I was trying to. I got the code. I'm pretty sure. Like this one is the one that was working, and then I got the head and all that stuff. But then I deleted a few stuff because I thought it was not working because of that, and then I was gonna reface it back in.
Which features were you interested in the data?
I was doing the head, the tail, and then I did the first 10, and then I did the linear regression.
Okay. Cool. Yeah. So see if you can get that fixed in yours.
Yeah.
Let me know. Like we can just have a separate call, and I'll help you to make sure that it's
Mhm.
Maybe James, I'll talk about it at the end.
Yeah.
If that's okay, I'll show you how to. This is just a slight problem that Nishant is doing. The file is actually zipped. You have to unzip it. You can do that by running a Linux command in the terminal.
Yeah.
By just preceding it with an exclamation sign. So Colab is providing you Jupyter Notebook layout. Jupyter Notebook not just runs Python code, it can also understand Linux or Bash commands. All you need to do is to just proceed with the exclamation sign, and it knows that it's a Bash command. And you can unzip files using it, and then make use of it.
Yeah. So there's I think today we've already gone over 3 different ways to import data into Colab, and basically anyone who got stuck in the past few days was texting me and had to do with this issue. So one of the reasons why we're doing something simple for the first project, so everyone gets familiar with data processing, which is the most boring part, but then always ends up taking more time. Yeah. So okay. Sol, which data set did you use? Sol, I cannot hear you. Okay.
Now,
Yeah.
can you hear me?
Yeah.
Okay, so I use the diabetes 1.
Yeah. Diabetes.
However, I got stuck at the beginning with the import of the data set. I was very late yesterday.
I know.
It's funny because I was trying to I asked ChatGPT to unzip the file, and then he asked me like, "Hey, would you like to perform linear regression to it?" I was like, "Well, yeah, let's test it out." and then at the end, I end up. Honestly, I was like, it's very late. I can just get until here, or I can use ChatGPT to help me out to work the linear regression, because what I was interested in is to find which is the correlation that was less obvious but more important when you are taking into account all the features, right? Because normally what is very obvious is that glucose, higher the level of glucose, more probable that you're gonna have diabetes. For example, 140 people out of 192 that had high glucose, they had diabetes. However, when you take into account,
do you have a chart?
yeah, I was working into
Let's see it.
Give me a second. Let me bring it.
So you got through it using ChatGPT's code interpreter. Is that right?
Yeah, it's a bit weird because sometimes it says I cannot do anything, and then another time say, yeah, of course it is. But
let's see if Sol can get through the whole course without writing a single line of code.
I'm not proud of it, but anyway, let me share the screen. Let's see.
It's
Let me know
really
when you,
resourceful.
let me know when you can see it better.
Yeah, you can see.
Okay. So okay, first I was like analyzing this heat map, right?
Yeah,
And then I was noticing like which were the main features of it. Um, and it called my attention diabetes pedigree function, which is basically genetic inheritance of diabetes.
and
And
did you drag a CSV onto ChatGPT, for example?
yeah,
Uh-huh.
yeah. Well, not CSV. It was a zip.
Okay.
It was a
Hmm.
zip file, and inside it helped me out to
Yeah.
uh, to bring it down. But let me show you the first chart where it is. Okay, here it is. This is the relation between glucose and the outcome. I don't know if you can see it well.
Yeah.
Okay, so I thought that this relation was the most obvious one because when I look into it, like 140 people out of 192 have diabetes with higher glucose level, right? But when I was looking into the numbers, let me see if I can. When I was looking at the correlation matrix, I don't know if you can see it here.
Yeah.
Um, wait, give me a second. Let me let me see where I can show you better.
So
Here
basically,
it
just
is.
just to clarify, you have a data set where it shows a glucose level in the person's body as the independent variable, and the dependent variable is whether or not they have diabetes, right?
Yeah, well, that was the feature I choose to
Uh-huh.
show the linear correlation because that was the most
Yeah.
obvious one in the beginning, and
Yeah.
then I started working out like which were other or like more interesting correlation features.
Yeah.
And let me show you something else here. One one moment. Let me change this chat because
But
this
could you
one
go
is
back to that? Could you go back to that last chart, that line chart that you had? I just wanted to point
yeah
something out,
yeah.
just while we had that open. Um, yeah,
So
yeah,
let me
that one. Could you
here
make
one.
that?
Yeah.
Yeah, make it a bit larger. So, I think Naveed and I are actually really happy that you chose this because this is a really. What do you think, Naveed? I think this is a pretty like it's not a great data set. It's a bad data set for linear correlation, but it's a really good data set for what we want to do next week.
Yeah. So it's a classification basically. The outcome is either a 0 or a 1.
Yeah.
So um, for classification, we modify linear regression a little bit. We apply some nonlinearity, which squashes the output of linear regression between 0 and 1. So it would be a perfect example to go over for the next algorithm, which is logistic regression.
So
And I'll
that's
show you why linear regression is not a good idea to do classification. So it's not like it's not possible using linear regression. You can have an attempt, but you'll see what are the problems with it, and why do we need to then uh, modify or come up with something different which would suit categorical data where outcome is from some categories, either binary category or more than binary categories.
It
but
makes sense.
there's no way you could have known that, which is why
I mean, I find it funny, like,
it's cool.
like how the binary part of it, like just 0 or 1. So,
Yeah.
so it was a bit weird at the beginning, but this is wait. What I really want to show you guys, I found very interesting. Let's see if I can. Oh, damn it! Let's see how here it is. Um, linear model evaluation. Give me a second. Let's see if it's this one. Yeah. Okay. So here's the other part. So when I was doing the linear regression, what I noticed is like when you are looking at separate features itself, of course, glucose is the most obvious one. and it's keeping on going this line down. But when you have a correlation of the features, actually, what I will start noticing is that diabetes pedigree function is the highest one when you take into account all the features together. So I found that interesting. That's why I asked you to create this chart for me to be able to show you that, guys. And yeah, well, there was many more things I explored to it, but this is what I found. This is the feature I found that has the most interesting correlation. It was less obvious, but the most important one when you take into account all the features.
And do you know how they calculate that feature? Diabetes pedigree function?
Basically, what I assumed that he was calculating is, in my simple words, it is like, yeah, you take into account all the features, and then when you take into account all the features, the people that have this high diabetes pedigree function, take into account the rest, is the ones who tend to have likely the outcome of diabetes when it's higher.
I'm looking at it now. It says it indicates it's a function which scores likelihood of diabetes based on family history.
Exactly. And it has these are the correlation coefficient, those ones here, and actually this one here shows us like the linear regression coefficient to it is the highest one when you look the total correlation. But anyway,
well, thanks Sol. It's really impressive that you managed to get that far and very resourceful of you. We will make sure that for the next one that you're able to import all the files so you can work with the Python directly.
Thank you.
Yeah,
Thank you,
James, are you going to do the multivariate regression now?
Yeah, so I'm gonna do
Okay.
I'm gonna let Aditya go, and then if we have
Oh yeah, sorry Aditya, I forgot about it.
he's still there as normal.
Yep.
If we
Sorry for that.
have a bit of time, I may just go over that quickly. Yeah. So that next
Okay.
we can move on to the logistic. Well, on Thursday we can.
All right. Yeah. So the data set that I used was the California housing prices. So let me just share my screen. There we go.
Okay.
Yeah. So the California housing data set. So there we go.
Isn't this the one we are using?
What?
I'm asking James. Is the one we are using the California house?
I think there was multiple housing data sets, right, Aditya?
Oh, okay.
Yeah, they were.
Yeah.
I think this is actually a different housing data set than the one we had. I'm pretty sure.
Okay.
Yeah.
So I did a bit of research as to how exactly one approaches a data set, and here are me like testing out different things and finding out what different commands do in pandas. And further down, I pretty much asked ChatGPT how to start off and apply linear regression onto the data.
Yeah.
So first it said you have to remove the duplicates and the single valued columns, and also need to remove outliers. So that's what I'm doing over here in these four cells. And further down, there is also like an object called ocean proximity over here, which has distances between the ocean and the land. And because it's an object, we have to reduce that into. I think ChatGPT said that it needs to be reduced into a single value columns instead of an object, so that the model can easily work with it. So that's what I've done here.
Did you create an entirely new notebook from scratch?
Yeah.
Okay. Yeah, you don't have to do that, just so you know, but that's cool.
Yeah, I was just trying to because
That's
Google
awesome.
Colab is
Yeah.
good and all, but I usually work offline on
Oh,
my
okay. Yeah,
device.
you work in Jupyter. Okay.
You
Yeah.
could have downloaded the notebook and worked with it in the VS Code as well.
If you want to.
This is Jupyter.
Oh yeah. Well, he's just saying that if you want to next time, you can also
Okay.
you can also use our notebook in Jupyter. We can
All
also
right,
use
cool.
the Jupyter notebook. Yeah.
Mhm.
But please keep going.
Yeah. So further on from there, this is where the linear regression theta ne is applied. This ChatGPT gave, I was trying to understand what exactly it is doing, but going back to the like questioning ChatGPT a bit more, I understood what exactly it's doing here. And further on, it is we are doing a dot transform operation on the data. That is by dividing it into train set and the test set. And after that, we are applying the root mean squared error, or like detection on not detection, like calculating the values basically. And then finally, we're fitting the linear regression model using the data that we have just transformed and the target data that we want to use. And this is a bit more of that exact thing. And this is totally chargeable. Like this part of it, I didn't know what exactly is it doing, but then I like Googled a bunch of questions and understood what it's doing. So here it's showing the different error differences between the actual data and the what linear regression has given. And finally, here's the output. So the actual cost of the housing, and then here's what it predicted in linear regression, and here's the error that is there. So this is pretty much what I did.
Cool. Well, nice job that you managed to get everything working from scratch. Let me just show you really quickly how you can actually download that into Jupyter if you want to for next time. You can just use like this, and then you
You
can go to
sharing screen?
File. Can you see? Yeah.
Yeah, there you go.
You go to
No.
File, Download, and you can do this. So, or we can just send you the notebook. But I mean, it's okay to do it from scratch, but it might just be it might take you more time, and you might have to figure out a lot of
It
things.
did.
Yeah, Aditya, you have done uh, you have done stuff that is like you have covered lots of things that we were planning to be covering over the coming sessions. So I won't get into them right now because that would be um, I'd have to like make the case for why we do the things that you have already done. So let's cover them in the future sessions.
Okay.
But yeah, you can ask ChatGPT to code the algorithms. That's a good thing to do because not you sometimes you would have to write the code from scratch for some problems. Majority of the problems that someone would have already done. So I think a better strategy would be to take someone's code and then try to modify it so that you can you don't make mistakes which you don't know of, because ChatGPT, although it's a very good coder, like it can code stuff for you, but since you don't know the premises of what you are trying to solve, it can be doing things that are totally not required, or make you go ways which you shouldn't be going. So that's why um, the goal here is that we provide you the notebook and you try to modify it to see if you can make it work for your own problem. Okay, before James, you introduced the multivariate regression. There are just a few things that I quickly want to talk about. First thing is the data standardization, which is becomes crucial when you are doing multivariate regression. You see my screen, right?
Yeah, no, we do only have 10 minutes left, but yeah, take your time. Just,
Okay, maybe you can then cover that in the next session. I think it won't take much time um, before I begin with the logistic regression. What do you say?
Um, yeah, I think like I don't want to assign people to do a multivariate regression. Basically, we just want to show you how you can. Basically, we just want to show you how you can add more variables into your linear regression to make it more accurate. So, for example, maybe the students' grades are based off of how much they drink and how much they exercise. We just want to be able to show you how to do that. But yeah, I think if we can do it in 15 minutes right now, then it's probably fine. And then next session, we're going to get on to more complicated, more sophisticated stuff. If that makes sense. Let me add you.
Okay, so let's consider this hypothetical data. If you want to do multivariate regression, you're going to have multiple such features. Currently, what James showed you in the beginning one is that he used area in order to predict the price. But what if you want to use more than one feature? Now, there's a concept called like, can anyone tell me what peculiarity do you see in this data, in these two features particularly? In these two, just a general thought.
Sorry, what was your question?
Question is, what do you see not something odd here between these two features? We have area, we have a number of rooms.
Like the area is. Go ahead. Sorry.
I was gonna say the one with more area had less rooms, which might be intuitively strange.
Okay, and what were you saying, Saul?
No, exactly. It has like less area, more rooms, higher price. Does it?
Okay, yeah, that might be something that was completely by coincidence because I just threw these numbers. The point that I was trying to you people to notice is that the scale of these two features is very different. So this one is varying between 4-digit numbers, and this one is varying in just 1 digit, right? So if you are trying to do linear regression on it, in this case, the output, the hypothesis function would become W1. Let's call it X1, and let's call it X2. X1 plus W2, X2 plus B. So previously, when we're using one feature, you just had y equals to wx plus b. Now you have two features, x1 and x2. That's why we have w1 and w2. Now, if you want to train this algorithm, you'd have to update the values not just for w and b, but also for w1, w2, and and b. The story stays the same. The gradient descent equation stays the same. So if you want to update the value for w1, the equation says w1 minus alpha times the derivative of the cost function with respect to w1. If you want to do it for W2, you do it, just replace W1 with 2. So if I plug in I here, this becomes Wi minus alpha times dj over dwi, where I could be 1 or 2. And then you do the same for the bias term. So the story stays the same. The problem here is because the scale of these two features are very different, and linear regression, as you can see, is just a mathematical formula which computes an output. Um, the the contribution at the output that would be coming, there would be a majority of the chunk coming from this region, from this term, because it is the area one, and area has numbers which are very huge. And this one, because it is the number of rooms x2, it is just it's varying. It's a small number. So even if the area stays the same, like 3156, and for one house the number of rooms were 3, and then for a different house with the same area the number of rooms was, let's say, 9, we obviously think that the house with 9 rooms should cost way more than what the house with three rooms were there. But because the numbers is so small, the difference in the price would not be very high, because of this number, because of the scale of it. Even though we think it should be high, it's not high. In other words, the algorithm is paying more attention to this feature than that feature. It's thinking that this one is something more important than that one. Why? Because the number is high and it's just a mathematical formula. So we cannot just directly take these features and feed them to our algorithm. We first have to normalize their scale in order to bring them into a common scale. Not change the values of them, of course, but change the scale of it so that they vary on the same scale. This is called data normalization. There are two ways you can do that. One is, the term that is given to it is called data normalization, and the second one is called standardization. Standardization. So let's look at the standardization one. This is one we'll be using, even though you can try that one as well. So what it does is it takes the value in a column. For instance, we're talking about the area column, which is x1. So it's going to the x1 column. It's picking values in it, and it is modifying them in this way. So let's pick a value x11, where this top one represents the first example in the data. You can think of it as this one. And what it is doing, it is separating from it the mean of the column. So mean represented by mu of x1, and then it is dividing it by the standard deviation represented by sigma of x1. And it is doing this for the entire entries of that column. So it's not just doing it for x1, it's doing it for whatever number of values you have. The result of it is you'll see that instead of the values being varying between these high numbers, they then become varying between some small negative number and some small positive number. The relation stays the same. So remember, we are not changing the data. You cannot interfere with the data, but you have reduced its scale so that now they can vary between a small negative number and small positive number. You do this for the area, and you also do this for the number of rooms column as well, and whatever other feature you might have, you do this for all of them so that your scale remains the same. And when you are doing linear regression on it, it doesn't bias towards a particular feature more than any other feature. So that's what James would show you in the next session, quickly, just showing you how to do standardization in the code. It's simple.
Yeah,
Scikit is the tools for it. You don't have to worry too much about it.
yeah, I'll do it. I'll do it now. We still have 5 minutes. And
Okay.
it's 5 months.
So you can quickly do that, James.
Yeah, that would be great. So that next time we can move on to something better. So this is the course materials here, and here under the mini project we just did, we actually had 2 notebooks, but we just asked you to do the here. We actually under the mini project actually had 2 notebooks, so we asked you just to do the first one, and I'll just show you. This is the one that you just did just now, and when we chose the feature that we wanted to do a linear regression on, we did something like this. It's kind of weird with the double brackets, but this is just in NumPy how you can select one column out of a data frame with lots of different columns. So that's how we did it before, and now I'm going to show you with the multivariate regression how we will do it differently, because now we want to select actually multiple columns. So, and yeah, feel free to go look at the code afterwards. So what I've done here is I've taken houses, which is the data frame, and before I would have been doing something like, this is the column that I want here, but Now, actually, instead of just selecting one, I'm just removing the ones that I don't want. Because it's very rare that you would actually want to use every single feature in the raw data. You'll have stuff like the ID, the date, and you definitely don't want to train it on the dependent variable, because that's the one we're trying to predict. So we take those out. And yeah, so that results in a slightly smaller one. In this case, I decided to just keep everything else. If you want, you can choose. If you want, you can also do something like this, where you just select the ones that you want to keep instead of the ones you want to remove, but getting a bit into the details here. So then after that, the important thing is what Naveed just said. He said, if we try and train this model without standardizing the data, it's going to be way skewed towards certain features that have larger magnitudes. So yeah, that's why I said I could do this in a few minutes, because this is literally the code for that. We take X, which is this whole data frame here, this table, and then we put it through fit transform. So that is something that you can look up, standard scalar, but it's just what Naveed just said. For each feature, it takes every value, it subtracts the mean, and then I believe it divides it by the range of values.
Standard deviation.
Oh, the standard deviation. Thank you. So in that sense, they're all normalized by that really simple formula, and then the rest of the training is exactly the same. So you just do we take the X norm now instead of the X normalize, and we do a train ket split on that, and we pass that into the same fit function, and what we end up with is we end up with a new model that takes into account all those variables. And if we would just look at the single variable model performance here, we were getting something like root mean squared error of 267,000, and here we get 198,000 once we've done the multivariate. So that's good. That means that it's improved. It hasn't drastically changed it by an order of magnitude, but we've gotten a significant improvement in the performance of the model by adding more variables. Does that make sense?
Yeah.
Yeah.
Cool. So feel free to play around with that with your models, but next time we're not going to share more or present more. We're going to just go into the next kind of regression, so that we can get to the fun stuff, which is the deep learning, as fast as possible.
Sounds good.
Sounds good. Thank you.
Sounds good.
You were asking me something?
Oh, did you have anything to add?
No. So we'll meet next time.
All right.
Yeah, thanks, guys.
Thank you, guys.
Goodbye.
See you next time.
Bye, guys.
Bye bye.